In our yesterday discussion, we had something discussion with respect to the basics of DevOps. DevOps is a culture which is used to provide agile methodology for development activity as well as the operation activity. The development activity involves the team of developers and testers. The operation activity involves the team of network engineers, inter-network engineers, database managers, and storage managers. These are all the persons which involved in the operation. These are all the persons involved in the development. So for making both the peoples integrate, so by making both the peoples to work together, we go for DevOps. Initially, in the opposite process of the traditional water model and agile technology, the focus is only meant for developer only, and the focus is not meant for operation purpose. So the development activity might have been quickly developed, but in terms of operation, it lack a problem. So as we told, there is a touch between a developer and the team and the operation team. What are all the problems that has been faced is pointed out by each and everyone. Developer may point a finger to operation team. So we have the correct thing. It is the problem associated with the implementation. Similarly, vice versa. The operation team can point their hands in case of any issue to the developer. So by adopting a culture like DevOps, both the team from the starting of coding up to the implementation, that production, both the team will know each and every other. The activity that is done by developer is aware to operation team. The activity done by the operation team to is aware to the developer. Both the team work together in a association with each other. Therefore, any problem that is faced by the client need to be addressable by both the people. They can't able to point the finger as that of in the previous techniques. Okay, so this is the way by which we can go for. Here, DevOps stands for main purpose of going for DevOps is automation of all the activity. Starting from development, we call this as a continuous development and continuous integration. Okay, so continuous testing, and then we call this configuration management. Okay, continuous implementation in the production, and here too we have a continuous monitoring, and by getting the feedback the activity will be continuous. Okay, everything is automated. This is the start and this is the final stage, and based upon feedback each and everything is repeated. Okay, this is the way by which you can go for DevOps. So for the continuous the development and to maintain those coding associated with the development, we need to go for the tools like GitHub, SVN. So this is the tool that we are going to develop. So the today's discussion we are going to discuss about the concept of SCM. Okay, SCM stands for Software Configuration Management. Okay, Software Configuration Management. So we call this by other name VCS, Version Control System. Either we call it as a Software Configuration Management or Version Control System. Both the thing is pointing out how to write a code and how to manage the code and how to keep the history of all the changes made by the developer on top of the code. We call both SEM as well as VCS, version control system. Okay, both the things are same. Once the code is developed and it is managed by this version control system, then the code need to be compiled. So for that, the code, for example, you may write a code in Java. So let me take sample.java. The file need to be compiled into class files, sample.class file automatically. So this sort of compilation, during compilation it will check for syntax error, it will check for semantic error. In case of any error, it won't check for any business logic error. You want to be very careful. Checking the syntax and semantics and converting this source code into the object code. Okay, source code into the object code. That's machine understandable format is taken care by the compilation. Okay, for that we go for tools like Maven, we go for tools like Ant, we go for tools like Gradle. Okay, here these are all the some of the tools that we can make use of for automatic compilation. Once the developer write the code and the developer place the code in this SEM tools like Git or GitHub, automatically what happens here, being it is automated, the tool either the and whatever thing that you have configured, will look for, here is your GitHub, the repository. Okay, so here the coding once it is placed, the code will be taken by the Maven, and what the Maven will do, it will compile the code and check for syntax and semantics. If the compilation is a success, automatically what we will do, so we have some test cases. Then the testing tools, like we can make use of tool like Selenium, we can make use of tool like JUnit. There are several tools, so I am listing you something, that's all. Okay, so here by the automatically once it is perfectly compiled, the next process in the life cycle is the testing tool. It will have some test cases. So okay, based upon the test cases, it will take the compiled code and it will run the code by applying the test cases. If the test fails, and it will inform to the developer. So this particular aspect, for example, that you make a simple analogy. So in your yesterday itself we have discussed a particular field. If it is marked as a primary key, then the possible test case associated with the field is, they will try to input 1 2 3. Okay, it is working perfect. You will try to input 1 comma 1, it should not work. You will try to insert 1 comma null, it should not work. These are all the test cases. If any one of the test case fails, for example, instead of rejecting 1 and 1, if it accept, then the test case will fails. Immediately the feedback will be given to the developer in this field which is marked as a primary key, the employee number, it accepts the duplicate value. So the developer will do the immediate modification to the code, and once the code is modified, even if you have a small single character change in that code, the initially developed code, let me make it the program 1, initially developed program. So after in this particular area of automated testing, it detects a issue. Okay, this particular code is allowing 1 comma 1, it will be immediately feedback sent to the developer. Developer what it will do, it will do the needed modification according to the requirement in the code, and the program, he will maintain that the program 1 as a version 1, program 1.1. Okay, it is the modified version of program 1. Similarly, if any other modification, program 1.2, program 1.3. In this manner, this is the first version, this is the second change, this is the third change. Each and every change will be managed in the particular tool. Okay, the SEM tool, the software configuration management tool, will keep track of what are all the changes that we did on the particular program. Even if there is a change in a single bit, it will be recorded as a new version. Okay, after that, once the new version is inputted, after the developer made the needed change, and he will store the change in the particular SEM repository. So the what happens once the new version is updated here, these tools will take the tool Maven or Ant or Gradle. What it will do, it will fetch the particular program and it will again compile the program to make the program into the source code into object code. Once it is properly compiled, in case again if it is any error, then the error also notified to the developer. Then the developer's responsibility is to correct the error, and once the error has been corrected, a new version has been registered for that code, and this tool Maven will take the code and it will compile the code, Once again it will apply the test cases, and then if the test cases got succeed, then it will mark it as a success. So similarly, we have several tools. Okay, we have a single program may consist of several things. This is the code used by the okay. This is the code used by the developer one, and developer one. This is similarly we have multiple developers. Developer two. These are all the models. Imagine these are all the models. Three models. Developer one is responsible for model one of the particular product, module two, and module three. Okay, there are three modules in the particular project. Each and every module will taken care by the developer. Developer right there. Here, this is the ACM version control system, and all the peoples will manage the code here only in version control system. From version control system, and this tools like Maven or Ant or Gradle, it will make a compilation. Then once it is successfully compiled, we have continuous testing tools. The testing tools may be JUnit, etc., and it will have some test cases, and it will apply the test cases, and if it is okay. Similarly, all the each and every developer, they have a particular code or particular component. Okay, so each and every component will have stored in this version control, and it is compiled. So now we have three modules got successfully compiled, and all the three modules has been tested, and it is marked as pass. All the tests associated with the three modules has been associated with pass, and it need to be integrated as a single entity. We call this as a configuration continuous integration, or we call this as a configuration CM, continuous integration or configuration management. All the individual module need to be integrated. And this sort of integration will be done by automatically by tools like Chef, Buffett, Ansible, etc. Okay, so we are dealing with Ansible and Chef. So once it is integrated, and it need to be implemented in the production. Okay, you need to be implemented in the production. It also do not only integrating all the component, it also set the configuration files. For example, here the particular software is associated with the web server. Therefore, what sort of thing that we need for web server, we need to configure some Tomcat, or we need to configure some Apache web server. So these are all the associated tools that we need to configure. So all the tools associated softwares and the hardware needed. Okay, for example, if it is a database server, we need to have a load balancer need to be configured. If it is load balancer, there should be minimum two servers, server 1 and server 2. So all the infrastructure based settings and all the associated softwares will be taken care by this configuration management. So Chef Buffer Ansible, after getting the associated compiled and tested component, it will integrate the component, and it will launch the appropriate system with the needed hardware and with the needed software. So for that purpose, it make use of some Dockers, it make use of some tools like Vagrant and Dockers and containers. Okay, so this is used to provide the infrastructure. The infrastructure for the particular software will be provided under the guidance of this configuration management tools. So after that, the infrastructure has been provided, the needed servers, the database server or load balancer, like so the machine got implemented. The entire project got implemented in the infrastructure as specified by the configuration management tool. After that, this need to be monitored. This need to be continuously monitored. The monitoring in sense the performance related monitoring, the application related monitoring, the high availability related monitoring, the database in terms of database, the free space, used space related monitoring, all sort of monitoring will be done automatically. So for that we go for several monitoring tools. We have several tools are there. Here the monitoring tool that we are going to make use of it and Nagios. In case any issues, once again the feedback is given to the developer. The developer will continue the activity. If there is a problem facing here, each and every stages it can be give a feedback during this compilation stage, during the testing stage. In each and every stages the feedback can be immediately notified to the developer community, so the developer community can do the needed change. This is the thing that we have discussed in the yesterday session. This is the flow. All the activity will be automated. It is the responsibility of the DevOps engineer to do the all sort of activity. Automating all the thing will be taken care by the DevOps engineer. Okay. So this is what that we have discussed in our yesterday's session. Okay. So development and building, and in the production we have a quality analyst, user acceptance testing. These are all the testing component, and everything is perfect. It will be implemented in the production. Okay. So recall what is DevOps. It is not a particular tool. So DevOps is not a single tool. It is not a single software. It is a combination of a set of tools by which we can make the entire task starting from development unto implementation can be done automatically without the user's intervention. When a user need to intervene, if and only if there is a issue. Else all the activity will be automated based upon certain rules that we have specified. We have certain rules, we have certain methodologies. Okay, accordingly the process will be automated. So by the way of applying DevOps, the advantage is both developers and operations will work together in a single manner. By the way, any issues will be given a much more focused attention by developer and admin, and it will resolve at the earliest. Okay, this is the generic definition for DevOps. Okay, so who will be involved? These are all the guys who involved in the DevOps. Developer develop the softwares. The build team will build the softwares. It will build the infrastructure. Okay, the system administrators is responsible for establishing the infrastructure. The network infrastructure and storage team is responsible for establishing the internet working and storage related things. And the release team's responsibility is monitoring what are all the process that is going on, whether all the process can be released on a particular date, and how to release. These are all the entire team of people so involved in DevOps. Okay. So with this here we have discussed about lot of tools. So the tool that is the configuration management tool, just now we have discussed, is used to deploy the code in multiple servers parallelly. Okay, so how to deploy the code in multiple server parallelly? So in this case, multiple people, once everything is perfect, the particular software need to be utilized by multiple peoples. Okay, in the client environment, the software need to be utilized by the multiple peoples in the production. So here, the developer may use a particular operating system. He may develop it in his laptop. Using example, let me make it a Windows 10, a particular version of Windows 10. He may use Java JDK 1.8, a particular version. He may use a web server, Apache web server of particular version. So all the code developed by the developer may work here in a proper manner. So the similar thing, if it is implemented in the client, it need to follow the same set of operating system, the same language, and same the not only the tool, also the associated versions and subversions need to be same. For example, if a developer is using Java 1.8 with imagine the Ubuntu 16.04, the same in the client side they have the operating system Ubuntu 16.04, but if the client try to install JDK 1.7, it won't support. Therefore, what they need is in the developer environment, similarly in the testing environment also, what are all the associated softwares a developer used need to be implemented in the testing also. Okay, in the client environment also, you need to go for using the same thing. In the client environment, you need to go for the same thing. So please wait a while. Sorry for a disturbance. Okay. So actually, yeah, Madhu, a newcomer.
Yes.
Yeah,
Hi,
yes,
Raman.
yeah, yes, Madhu. How are you?
Yeah, I'm doing good, Raman.
Hi, Divya. Good morning.
Yes,
Oh, yeah. So we are just recalling what we did in our yesterday's session. Okay. So this is the workflow associated with the DevOps engineer. Okay, that the developer will develop and all the associated code will be managed by the version control system. And once it is placed on this version control system, it will need to be compiled. Tools like Maven, Ant, and Gradle will compile the code. Please, Divya, you mute yourself. In case of any clarification, you can unmute. Thanks. Okay, we have tools like Maven and Ant. It will do the compilation part. Then if it is perfect, and then the tools, the testing tools will have some test cases associated. Tools like JUnit or Selenium will take the compiled code and it will apply the test case on top of it. And if the test is succeeded, it will make a mark of a pass. And let me imagine that a particular product involved three developers associated with the three modules, and all the modules when it is successfully completed the test, we call this test as a unit test. Each and every module we call it as a unit test. Once the unit test is successful, all the three modules need to be combined as a single entity. For that, we need to go for this continuous integration. Tools like continuous integration tools, and there's tools like Chef, Puppet, and Ansible will do the activity of continuous integration. And after integrating, again, once again, it will apply this integration test. So the tools may exist, the tools may work properly as a unit test, it may work properly. But during the integration, whether all the tools, all the associated modules is working coherence with each other without any issues. That test is called integration test. Once again, the integration test will be done automatically. The tools like Chef Buffett will take care of doing this integration test. If everything is perfect, that the entire software, build software need to be implemented, then the infrastructure needed for the implementation once again will be initiated by this tool, configuration management, all the associated configuration. The configuration refers to the software configurations and the hardware configurations needed to run the particular project need to be incorporated. So for that we can make use of this Vagrant, Dockers and containers. Initially we have this virtualization softwares. Now we have they are implementing this in cloud. Okay, these are all the tools which provide the needed infrastructure, and the infrastructure may be implemented either in a virtualized environment or in a cloud environment. Nowadays cloud environment is more recommended. So here this Chef and Ansible and Puppet will do the activity of integrating and creating an environment and landing the particular compiled full version of the software to be configured in the environment. The environment is created by the opposite tools. Once it is running here, it will be monitored by some monitoring tools for performance monitoring and the user access control monitoring, any some security related violation monitoring, etc., etc. And each and every phases, as I told, will have a feedback. When there is a problem in this phase, while compilation or while testing, immediately it will be notified to the developer, and developer will do the needed thing. Okay, so in the development environment, in the testing environment, in the compilation environment, in the client environment, each and everything we need an infra. How to manage a similar infra? So in terms of OS, for example, the developer uses Windows 10 or the developer uses Ubuntu. So the same set of language, the same set of services, associated services need to be installed in all the environment. If not else, let me take this example. If the developer uses Ubuntu 16.04 and Java JDK 1.8, but in the environment in the where it got implemented in the production environment, if Ubuntu 16.04 and the client if he install 1.7, it won't work because of the incompatibility of this versioning. Okay, the version 1.7 won't have a support for Ubuntu 16.04. Similarly, if it does not contain any needed services, it may also result in some issues. So these sort of things need to be resolved. How it can be resolved? So we make use of these Dockers. Docker output, what it will do? It will create an image. For example, it will create a Ubuntu image. It will configure needed softwares. It will configure JDK. It will configure needed services, everything. And this image will be shared. That everything is configured according to our requirement, and the image will be maintained in one central repository, a global repository. So if a developer wants, the developer will connect to the repository and it will get the image. On top of it, he will work. The tester will connect to the central repository and he will get the image and he will work. Similarly, in the production environment also, all the associated peoples, the client who is going to work with the particular software will be configured a machine with the image got from the central repository. Therefore, by the way, we can able to ensure the developer, the tester, the quality assurance team, the people that is going to work, the end user, the similar configuration. So if the problem associated with this conflict, version conflict, operating system conflict, services conflict has been resolved here. So these are all some of the way by which the entire process is automated. Then it is the role of DevOps engineer to take care of automation. Yes, am I making sense? If you got any doubt, please let me know. So the prerequisites for this purpose is, so for DevOps, you need to have some basic knowledge on networking. You should have some basic database related knowledges. You should have some basic operating system related knowledges. These are all prerequisites, basic knowledges. You should aware of some scripting languages. It may be a JavaScript or a Python script or a Shell script. And you should know some in terms of OS, Linux and Windows OS is sufficient enough. Okay, some basic entry level language is needed. Okay, so if you have got any doubt, please let me know before proceeding further. Okay, now, yeah, is it clear? What is DevOps and what are all the roles
Yes.
of, what are all the role a DevOps engineer will do? What are all the sequence of activity that need to be carried in this workflow from development up to implementation? What are all the tools that we are going to make use of it in our curriculum? Okay, these are all the things associated. So here we use for version controlling Git and GitHub. Okay, and for code building we use Maven. And for testing, if time permits, I will let you know. For testing also, we can make use of Maven. Later case, if time permits, we can go for this Selenium, one of the most demanding tool, automated. It depends upon our time constraint. And here we make deal with this Chef as well as Ansible. Ansible nowadays is gaining more popularity compared to that of Chef and Puppet. It is more flexible, more easy, and more comfortable. So we people prefer Ansible. We go for both Chef and Ansible. And for environment creation, we go for Dockers and containers. And for cloud, in terms of cloud, I will let you know how to create environment using AWS as well as Azure. Okay, both the cloud we will have a discussion. For cloud itself, we have a separate course curriculum. Here it deals with how to set up environment using this EC2, how to configure this load balancer like thing, how to configure this auto scaling, some basic thing, and then how to get a storage. Like these are all some basic services will be taught in both AWS as well as in Azure cloud. Okay, and then in terms of monitoring, we are dealing with this Nagios tool. So these are all the things associated with our curriculum. And apart from that, in case if you need any further assistance, if you need some additional sessions with respect to Linux operating system, which is because majority of implementation will be taken care by Linux. we can give a little bit 3 to 4 hours of additional sessions to if you people doesn't aware of Linux. So let me move on to the discussion of first tool. So what is version control system or software configuration management tools? What are all its main goals? What are all the keywords associated? Let me discuss now. Okay. First tool, SCM. SCM stands for software configuration management. Otherwise, we call it as a VCS, version control system. So in terms of this SCM version control system, we have two types of. One, we can go for a pay tool, or we can go for this open source tool. So the tools associated with this has been categorized into the following category. We need to go for some pay tools, or we need to go for some. So examples of tools that we need to go for: clear case. We have tool called clear case. We have tool called perforce. Okay, so in terms of open source, we have tool called Git, and the repository used is GitHub. These are all open source. We have tools like Subversion, SVN. SVN stands for Subversion. Okay, we have tools CVS. These are all some open source tools, out of which nearly 80% of today's IT world is making use of this tool Git and GitHub. Okay, so in terms of this version controlling system or SCM system, you need to aware of certain terminologies. The terminologies that you need to aware, okay, is you need to aware of the server client architecture of this version control system. You need to aware of these repositories. In terms of repositories, we have two sort of repositories. One is local repository, and another one is global repository, otherwise called as a remote repository. You just make a note of all those things. I will share you the recording, even though you just make note of all the associated things in a short manner. It will be helpful while recalling. So you should aware of workspace. You should aware of another concept called as branching. You should aware of this check-in and check-out. You should aware of commit and add commands. Okay, you should aware of these revisions. These are all some of the terminologies associated with our tools. You should aware of some baseline. Okay, so basic terminologies that we are going to discuss. Associated with these SCM tools. Okay, so what is SCM? SCM is software configuration management or version control system. What is the primary intention? What is the primary aim of going for this version control system? The primary aim of going for this version control system is to keep track of all the changes that we made to the history of the particular software. Okay, keeping track of all the changes that we made by the developer on the particular software. Okay, even a change in a single character or a change in a single word or change in a single bit is recorded. Okay, so initiate, that is the main intention, keeping track of history of changes in the software that is going to be developed. Okay, so that is the main intention of going for this version control system. It plays a crucial role tracking and controlling the changes in software during the development life cycle. This is the first phase of the workflow associated with the DevOps life cycle. The main intention apart is to keep track of changes, and what is the advantage of maintaining these changes and applying this SEM and business controlling system. The main advantage is to work people in forms of teamwork, the teamwork. So both the development team and operation team work together, and what are all the work associated with the developer will be aware to operating system, will be aware to the infra team, and what are all the things need to be done by infra will be aware to the developer team. Then there won't be any conflict. In case of any conflict, both will work together to resolve the conflict. Okay, so that is a teamwork. Then defect tracking. At any point of time we can able to defect. The defect, in case of we have a defect can be tracked. Okay, since we are maintaining different versions. Example, initially the program 1 is version 1.1, and we did some changes program 1.2, and similarly we did some changes, it maintains 1.3. If we feel that 1.3 is not working properly, we need to go back to 1.2, then we can also revert the changes. Defect can be tracked. What is the problem associated with 1.1? How the problem has been resolved by 1.2? Then what is the necessity for going for version 1.3? Everything is recorded. That is defect tracking. So here, and because of the opposite, we can make the process management as a automated activity. Okay, the process management has been made automated. So these are all some of the advantages of going for the appropriate tools, SCM or version control tools. Okay, so what are all the information that is managed by this particular version control system? So we say that keep track of history of changes. What are all the changes that will be managed? The main thing that is managed under this, who did the change? That is the name of the developer of the particular module. Then sorry, who did the change? Why the change has been done? What is the necessity for changing that? For example, initially version 1, we have defined that the particular employee number is a primary key, but it is failing. It allows 1.1 comma 1. The employee number, if it is set as primary key, it should not allow duplicate value, but it is allowing duplicate value. Therefore, to resolve from that, we did a modification in the code, that is version 1.2. So those sort of information is recorded. Why the change has been made? When the change has been made, the date and time at which the change has been made. What is the status of the change? If we change the code, whether it is successfully resolved what problem that we have faced, whether it is successful with respect to the intention of change, everything will be recorded here. So who did the change? The developer name. What is the necessity for making the change? So in this example, being it is initially the particular code is specified employee number as primary, it is violating. So to resolve, we did the change. When the change has been did, the change has been did at 1 January 2017 is the first change. Then what is the status of the change? Because of the change, whether we can able to achieve what it is intended for. Yes, the status is success. All the thing will be recorded here. Okay, so to keep track of all the above said changes, we go for this SCM or version control system. Okay, here in terms of what are all whether we can able to record and manage only the software code only? No. Apart from this coding, the software code, we can also manage documents also. We can also manage some log files also. Anything that we need to maintain, we can make use of SCM. Okay, for not only it is specific for coding, for recording log files, for recording documentation, everything that we can make use of it for the purpose. Okay, so here we are going to discuss about the tool that we are going to make use of it. Git. Git is a tool, and what is the difference between going up with the Git and GitHub? So Git is a tool, then GitHub is a repository. Okay, so this is your site. The developer, let me imagine that this is the developer who is developing the particular code. Okay, so here the developer uses Git to record the changes, to store the changes, everything. Then here the developer may have a local repository. The change and the storage area associated with the developer is called as local repository. Similarly, we have multiple developers. Okay, the developer may develop the module 1. The developer 2 may develop a module 2. He may have a local repositories. Okay, all the changes, what are all the things that he did will be maintained here. Similarly, the developer here. So he is working with the module 3. So all the changes need to be registered under a global location. For that, we need to go for GitHub. GitHub is a global repository. Global, we call it as a distributed repository. Version control repository. It is a global distributed version control repository. We'll be discussing about shortly about what is distributed and what is centralized. What are all the advantages of going for this distributed concept? Okay, so GitHub. So what are all the things? This repository is global. What are all the things that the developer is maintaining in the local repository will be synced with the global repository. All the activity done by the developer. These are all the developers associated with a particular project. Okay, a project XYZ, and everything in GitHub we have a separate area associated with this project XYZ, and all the code will be shared here. Okay, the code is available both in this GitHub as well as in the local repository. In the local repository also the same code will be available. So here the developer may do the changes in the local repository, and after that if everything is perfect, he can update, he can sync the content with the global repository. Okay, so this is the theme associated with the local repository and global repository, and the developer may use this tool Git, and GitHub is a repository which is used for storing and sharing all the associated coding is called a GitHub. Okay, it is a global terminology. So what are all the main features associated with this Git? The main features associated with this Git is, so speed. I will let you know discussion for each and everything. Just make a note. Speed. Okay, it is a fully distributed model. The advantage of going for fully distributed and non-distributed we will discuss tomorrow. So it ability to handle with a very high efficiency, highly efficient. In case of very large project, we go for concepts like branching here. By applying concepts like branching, so I will let you know what is branching in subsequent classes. Then more importantly, we have lightweight components. What is lightweight? All the associated thing will be aware to you or tomorrow. Lightweight components, fully distributed, how it achieves speed, what's the advantage of going for fully distributed, what's the difference between fully distributed and centralized, what are all the tools which uses this adapt this architecture, then what is by way of branching, how it achieves overall efficiency, what do you mean by lightweight components, everything will be discussed. So these are all some of the key features, or we call it as advantages of going for this Git. Okay, so now we had a discussion on previous class. We had a recall of what we have discussed in our yesterday session. So what is DevOps, and what are all the core components associated with the DevOps process, what is the activity of a DevOps engineer, what are all the tools that we are going to make use for each and every activity, like development, source code maintaining, compilation, integration, configuration management, and automate the provisioning of infrastructure, and finally end up with the testing. What are all the tools that we are going to make use of in our curriculum? And we have started with the tool called Git, and what is Git, and what is the difference between Git and GitHub, and what are all the associated terminologies that we need to aware for Git and GitHub, like repositories, workspace, the client server architecture, branching, check-in, checkouts. Just we have listed out this terminology. The discussion of this terminology will be on tomorrow's session. Then what is the advantage, or what are all the key features associated with Git? Okay. So being it is time now, I am going to wind up today's session. If you have any doubt with respect to today's discussion, please let me know.